Welcome to part 3 of Competency 15. In this video, we will work with mathematical reasoning. Okay, so when we're talking about mathematical reasoning, we mean the difference between deductive reasoning and inductive. Okay, deductive, you will start with something general, either a formula or a description of a formula, or they'll just state the formula, and then you go to specific examples. Or inductive reasoning is you begin with a specific example and then you conclude a generalization of some sort, which in education, the preferred is the inductive reasoning. Okay. All right. And that the FYI, definitely gonna have a question off of one of these. Okay. All right. So let's look at number one. Go all the way up there. Okay. For the following statements, which is an example of inductive reasoning. So that's what I just talked about. We have to have a very specific situation. And when I say specific, I mean it has to give us like uh numbers only used for that word problem, or only a situation that is specific to a specific like numbers in a situation. All right. So let's look at A. Immediately, that flags as deductive. It says Pythagorean theorem. That's a formula. And then at the end, it gives numbers for a specific formula, which is your 3, 4, 5 triangle, your first primitive. So no, that is not inductive. Inductive would have been flipped. So let's get rid of A. Let's look at B. Any missing side of a right triangle can be solved with, nope, that's a formula. So it's starting with a formula. Then again, what this is, A and B are the same thing being stated in a different way. So now let's look at C. If the legs and hypotenuse of three right triangles are, okay, you have a 3, 4, 5. That's the first primitive. And then another primitive right triangle. That is 5, 12, 13. And then you have the 8, 15, 17. And when I say primitive, those are some of there's a long list of primitive right triangles. That means that they are always going to be a whole number answer. Okay. Meaning that it's going to be resulting with a whole number out of the square root. Okay. All right. So those are specific situations. They're not just any right triangle. And then it says with the hypotenuse equal to C, then the hypotenuse must be the longest of all the right triangles. So there has been a conclusion made from the given, which would be a great way to, once you introduce right triangles, like do something, an activity. There's lots of triples out there. And then once they work with a triple, then go to this and then ask the students, guide them into this conclusion, because it's a simple conclusion to make after, say, working with three you've got three primitives, so you would do those in a triple, a Pythagorean triple, like introduce them and then go to this and then lead them there. So this is like a perfect example of inductive reasoning. And it's a great setup. If you listen to what I was saying, you could tell I've taught this before in middle school and high school, right? Oh, even at college. So this would be a great way to show examples, or at the middle school level, actually have them do a little activity and lead them into this. And it could be done within a class period. So that's probably why this particular question is being asked. That's why they do this. Okay. Now let's look at D. Again, red flag. It starts just like A, so there is no way I would select that. Okay. All right. So let's look at number two. Number two, given the following statements, In a given triangle ABC, the measure of C is 90, the measure of A is 44, the measure of B is 46. Okay, that's one statement. Here's the next one. In a given triangle DEF, the measure of F is 90, the measure of D is 30, and the measure of E is 60. Is the claim the sum of the acute angles, that's the smaller angles, of any right triangle must be 90? Inductive or deductive? Okay, what they're saying is this inductive or deductive as far as the claim? Okay, and here's where we select. Well, they're starting out with very specific triangles, and then they're going to a general statement, not necessarily a formula, but that does the next step would be introducing the student to the formula. So you're going to end with the formula. So that would be inductive reasoning. Okay. All right. And if you haven't noticed, we are not using our calculator. These are the kind of questions that you have to identify that you're not going to use your calculator unless there's something embedded in it that requires a quick addition. And of course, yes, you probably should take these and add them up and these and add them up. Well, the second one you see 30 and 60 is 90. Well, we could go ahead and pop that in. Of course, you could also just eyeball it and see that that's 90 degrees. That'd be something you could quickly check if they don't state it right away. Okay, if they don't, or what they may do is say, okay, you are given these two statements. Now, which one of the conclusions would be inductive? So you would have to go, okay, what would be a conclusion? You'd have to add it up, and then you'd go through your A, B, C, D and say, okay, which one would be the proper inductive? Well, of course, it's given to us here. Okay, that would be the occasion to do that. All right, now let's look at number 3. Is the statement below deductive or inductive reasoning? Okay. Whenever equals are added to equals, okay, the results are equal. That is a huge generalization. Okay. And then they have given that M equals M. Those are general. There's nothing specific. Okay. And then they go to a mildly right here. That's mildly specific, not exactly, because 5 does equal 5. That screams deductive reasoning. There is nothing inductive about that. To make that inductive, you would have had to have had a list of equal items and then had the students look at that and have them, write something out or tell you or say, hey, could you turn that into a formula? How can we make that a general formula? What are you seeing generally? Then you're going to, start with all these specific. You could go groups, but that's the only way to make that inductive, right? Like if you had 3 groups and they each had the numbers, and then you say, okay, and make them work to the formula itself, but not this, okay? All right, so 4, is the statement below deductive or inductive? Here we go again. The product of two odd integers is an odd integer. Specifically, okay, that is a huge red flag of deductive, okay? Because this could not be a more general statement, okay? You could even turn that into a formula. There's ways to do it. So, no. Mm-mm. You could say odd equals X and even equals y. And you could say, you know, y, yeah, I'm sorry, x plus x equals, you know, 2x. That's basically what it's saying. So no, that's not gonna doesn't jive. It is it couldn't be inductive because here now they give the 9, 7, and 9 as specific numbers. Okay. All right. So let's look at number 5. Number 5, given the three equations, 5 times 8 equals 40, 10 times 3 equals 30, and 11 times 12 is 132. It would be nearly impossible to determine which statement would represent the conclusion. Okay. One statement would be the product of any two odd integers and even integers is always even. Okay, well, this is just something that you would want students to get to. Yeah, so like, is there trying to get the kids to see, oh, is there a generalization? Okay, well, I see even and odd is always even. So that in itself, we're starting with general. We're not looking at trying to make something out of the statements. What we're trying to do is say, is this inductive or deductive? Well, obviously inductive. We are beginning with specific values to get to this general statement down here. So 100% inductive reasoning. When you trying to, what they're saying is, they're just saying something generalistic, saying, hey, could you get the students to see that? Well, you would really have to give them some serious guidance to get them to see that. But a lot of kids have been exposed to it early on, so they might see it. If you gave them a list of statements, they might be able to pick the specific statement. Okay, which you might be given on a test, instead of just one statement. You might have the ABCD asking which one would be the proper inductive statement. Okay. Now let's go up. Okay. Number 6. The square root of the sum of two positive integers. I see it. Okay. Is less than the sum of the square root of these two numbers. Okay, this is what they're saying. Let's say we have x plus y, that will be less than the square root of x plus the square root of y. That is the triangle inequality formula. So that is obviously general. Therefore, they're starting from general and going to specific, which they gave you the numbers. And you know what? Let's pop that in the calculator. If you're not familiar with the triangle inequality, huge. I mean, if you don't have a 4-year math degree, which a lot of people taking this test won't, I understand. You don't necessarily need it. This is huge in proofwriting. Oh my gosh. Yes, I've seen that on many occasion. Not my best hour of proofwriting, right? Okay. So let's see what they have. They have 5 plus a 6. Okay. And that would be 11. Okay. Now let's add second radical 5. And you got to arrow over, guys, and then push your plus. And then second radical, let's put in our 6. Okay, I like to arrow over. You don't have to. All right, and let's push enter. So we're gonna have to toggle that. Okay. All right, let's go up and grab 11, square root of 11. Okay, and then we're gonna have to toggle it. Ooh, yeah. Uh, it's definitely greater. Absolutely interesting. Well, I say interesting, I already knew that. It's just something that we use when we're trying to prove specific i- uh s- specific things that you already should know, and there's other reasons to use it in proofwriting. Anyway, let's move on to number 7. In an equilateral triangle with sides S, the area is given by the equation red flag. You have an equation first. That means that's general, that's deductive reasoning. Let's go ahead and finish reading. Thus, if we are given an equilateral triangle whose side is 6, the area must be, and they give it to you. I always forget this equation and have to look it up. I don't know why, but it's a good one. You need to keep it in your repertoire. It's really good for testing and for if you get stuck with any of those questions where they ask you the properties of an equilateral triangle, okay? And rewrite it like this and remember it. I've made a bigger effort to remember it. The truth is, you should see it like this. So just say 3, 4, okay? And try to remember. Okay, and that's supposed to be an S squared. Okay, really, really handy, right? And trying to get those other questions when they're asking you about the properties. Go look that up and get yourself familiarized with that equilateral triangle and every property. That's very handy. I actually had a university-based question. Yeah, you have to take the practice test at the university sometimes before they'll let you go take the real thing. Okay, be that the 7 to 12 or the 4 to 8. So get yourself familiar with this before you go take that practice test. It will help you out. Okay, this is the last question for this video. Thank you, everybody, for listening to my writing and raving about these questions. I always like them because deep within them, there's elements that you need for the real test. You're like, oh, you're just asking me inductive, deductive. But if you analyze them, it helps. Trust me, I took it and I was like, oh wow, that was what was embedded in this other question I saw. And it'll click for you. So, and thank you again for watching, liking, subscribing, and sharing. You guys are the best. And once again, happy testing, everyone.